Welcome to Mixtures and Solutions Investigation 1.1 and 1.2. Let's go ahead and start off with what we have here. We have a cup with powder. We have a cup with salt. We have a cup with gravel. And the gravel is gravel you might see at the river. It's really just river rock. Then we have salt. And we have diatomaceous earth. And diatomaceous earth is actually a product of seashells and crustaceans. It's their shells that have been ground up, and they use diatomaceous earth to clean in like pool filters. So it helps to filter things out. We have water. I have a half a pint container. I have a syringe. I have a screen. I have some paper filters. I have a funnel with a cup underneath. So let's start off with what is the big idea? Why are we doing this? So our focus question is, how can a mixture be separated? So we're going to have these three areas right here that we're working with: gravel and water, powder and water, salt and water. So first we have just the straight gravel, salt, and powder in the cups. So now what we're going to do is we're going to use some water. So we're going to mix gravel and water, powder and water, salt and water. We're going to mix it up, and we're going to try to see how can a mixture be separated. So each cup will receive 50 milliliters of water. And we're going to observe the changes.
Hang on.
This is Stephanie. No, just fold it in half.
Wait, you're Stephanie?
Okay.
That's you.
All right. So we're still recording. Okay. So we're going to take a look at, I have a stick with G on it for gravel. And when you look at the container, here's the gravel.
Would it still be okay to drink that gravel water?
I wouldn't. Then we have salt. We're going to mix the water and salt together.
It feels like regular water.
What's happening to the salt?
It's dissolving.
It's dissolving. Nice job. Great vocabulary word. Then we have the powder.
The molecules stick together.
All right. And it turned into a watery, like milk liquid. That's what we noticed. Yes, Jose?
Maybe on the powder, the molecule of the powder and the water stick together to make.
Well, they're combining.
Yeah, the molecules stick together to make the milky liquid.
Okay. Now, so for the beginning part of this investigation, we looked at the color, the texture, the particle size of each one of these ingredients. We added our water, we stirred it up. Going back to our question, how can a mixture be separated? So now, what we did is then we went through and we wrote down what we noticed, right? What was the change? We recorded the change that we saw in each one of these, correct?
Mm-hmm.
All right, so now moving on to separation. Now, separation, we now have a chart with separation, right? Let's see. Here is the paper that we did for mixtures. So there's a part 1 and a part 2.
I have a question.
Then we're moving on to separations. So here's the procedure that we're going to go through, and then we're going to record our observations. Okay? Yes, James.
What is the powder?
I just described it. Diatomaceous earth. That's made up of crustaceans, seashells, that are all ground up, and they're used usually in filters to clean. Okay? Like you might find it in a pool filter. Okay, so now we're moving on to separations. So we are going to mark either yes or no. If I used a screen, could I separate the gravel, the powder, and the salt using a screen? We're going to check that. Then we're going to check with a filter paper. Were we able to separate the gravel, the powder, and the salt? Okay? So that's what we're doing next. So we're going to go to the screen first. So our screen, I'm going to put my water, my excess water back here. All right, so now we're going to first try the screen and gravel. Okay, so let's see what happens. Okay, so was I able to separate the water from the rocks,
Yes.
from the river rocks?
Yes.
Yes, we were, right?
Yes.
Okay, so now I'm going to take this. I'm going to scrape it off. Now, tell me why I was able to separate the rocks from the water.
Because there's a filter, and the rocks can't go through the filter because they're too big. And the filter's like miniature.
Okay, so I have a mini screen, and the rocks are bigger than the openings in the screen. Is that what you just said?
Yeah.
Do you guys all agree?
Mm-hmm.
Okay, perfect. Now, we are going to go powder. Now, I'm not going to use all of it because I need to save some of it. Oh, I need to save some of it for the salt. So I'm going to put this back in here.
What about the ground with the filter paper?
I'm going to put this back in here. Okay. Now, some of my rocks escaped off to the side. All right. Now I'm going to use the powder. But I'm not going to use all of the powder because I need to save some of it for the filter, okay? Okay. Now, remember our guiding question. How can a mixture be separated? Now, I'm going to use my screen. Now watch as I pour this in. Was I able to separate the powder from the water?
No.
Why?
Because
Zoe.
Because the powder and the water, they mix together, and because they mix together, they're like you can't really separate them apart.
You can't undo it, right? Because they're now combined together, right?
Yeah.
Okay. Now I'll pour this back in here. Now lastly, salt. The salty water. Am I able to separate the salty water, the salt from the water?
No.
No, why?
Because it's already in the water. You can't do
What's the word?
it.
It dissolved into the water, correct? All right. So now let's go through and now let's use a paper. So are you marking on your paper whether it was able to, whether we were able to separate? Yes, we were able to separate it, or no, we were not able to separate it. All right. So let's go to gravel. Okay. So I'm putting the gravel with the filter.
It's separated.
Was I able to separate
Yes.
the gravel from the water?
Yes.
Yes.
Yes, we were. All right. So now, can I separate the powder from the water? Watch him. Look.
I mean, it's
Hold on.
still milk white.
I should have stirred it a little bit more.
Oh, that's all powder.
Okay.
Yeah, it's on your
Okay.
right. Let's go from the no.
It's separated.
Now, so here's our gravel.
It's still milky. What? It's separate.
Okay.
Did it?
I don't know. Let's look.
Yes.
Yes. Really.
The word last time is over.
All right.
Squishy, I told you yesterday.
Was I able to separate the powder
Yeah.
from the water?
Yes.
Yes. Now, why was I able to separate the powder from the water using the filter?
Because
Emmanuel, say it again.
So the powder, it's bigger than the little
Holes.
in the filter.
So the filter paper has such fine holes. Is that what I'm hearing you say?
Yeah.
And the powder is bigger than the really fine holes in the filter paper, right? Am I saying what you're saying?
Yeah.
Okay. All right. Now, finally, we have salt. Now, can I separate?
No. It's a no. Yeah, I say
I'm going to put this in here. Okay. Can I separate the salt?
no.
Am I able to separate the salt from the water?
No. But if you boil it,
Oh, interesting that you say boil it. What did I bring out yesterday? The evaporation tray, right? And we took some salt, the salt water, and put it in the evaporation tray, and the evaporation tray is now sitting outside to try to see what's happening, right? Sitting in the sun. Now, yesterday we did this and we let the powder dry.
oh,
So the powder that we did yesterday, the powder dried. Yeah, it's back. So it turned back to the powder, didn't it? Okay.
I think it all the water got dried out.
Okay, so a couple of things I want you to add to your journal. So find an open space that you can write some of these notes down. So, did we answer the question, how can a mixture be separated? How can a mixture be separated?
by drying.
Yes.
You have to heat it. Powder, you have to distill it. Or whatever
So,
that thing machine is.
Filter. So you have to either filter it, right?
Filter it.
So filter it using either a paper filter or a screen. But in order to use the screen, your objects have to be larger than the holes in the screen, right? Yes,
You have a microwave, right?
Yeah.
I do.
Put the salt in the microwave.
Okay, but we have it out in the sun right now to try to see what it's going to do.
Put 5
Yes?
minutes on that. Could you also maybe use one of those grapes where like you put it in the water and then you like pull it out?
Oh, like you do when you're panning for gold?
Yeah.
Kind of thing? No, I think it's because remember the word that we used was dissolve for salt, right? So when it dissolves, it becomes part of the water, right?
Not part of the salt.
Okay, so let's write down a few words. Solution. All right, a solution
Is a problem
dissolves
that
in
needs
water. It means, let's write
It's solution. Yes.
a liquid
Like what? Why does that look like a box or something?
dissolves in water and cannot, together, be easily separated. Because in order for it to separate, it's going to have to use evaporation, right? Yes? All right, let's write the word solute. A solute is a solid that dissolves Okay, so a solute is a solid that dissolves. So what can you tell me here? What here was a solute?
So,
The gravel.
But did it dissolve?
No.
No.
Salt.
The salt?
The powder.
Yes. Okay. Now, the difference between a solute and a solvent, the solvent is the water. It's the liquid. So you add the solute to the solvent. So the solute goes into the solvent in order to dissolve.
Is that for a solution? Like,
Yep. So here's your definition. Okay. Now, couple more words. We're going to look up the word mixture, dissolve, so we already have solution, solute, solvent. Now, I'm going to challenge you to look up the word mixture and dissolve and add that to your notes. Because this is going to help you answer the focus question again. How can a mixture be separated? So who can find the definition for mixture? Daphne.
I found a substance made by mixing other substances together.
Okay, we're going to take it down even smaller. Bradley.
the process of mixing or being mixed.
Okay, anybody else?
That's the smallest one.
Yeah, that's the smallest.
A combination or different qualities, things, or emotions in which the component elements are individual.
Okay, that might be a little complex.
A person regarded as a combination of qualities and attributes.
Did you just say a person?
A person.
Okay. But we're just talking about, we're going to talk about just mixtures and solutions.
That's what it said.
How about two or more materials together? How about let's just make it that two or more. Two or more materials together. All right, and the word dissolve. Who can give me dissolve? Go, Tristan.
Become or cause to become incorporated into a liquid so as to form.
Okay, that's really complex. Let's try to make it really simple. Fernando.
Closed down or dismissed an assembly or official body.
Okay, that doesn't have to do with this though. That has to do with like government or businesses.
I know.
Really, I didn't know people shouted out at me. Jose?
When one thing overpowers another, the other, the smaller thing disappears.
Okay, yes, but we're gonna make it simpler. Braylon.
To make a solution.
Okay, how about, okay, yes.
The process of combining one ingredient with another
Okay.
to form a solution.
Okay, I like that. I like that a lot, Bradley.
Solution of.
Okay, so I'm gonna add to that, Bradley. I'm gonna say a to dissolve is when a solid disappears into a liquid. When a solid disappears. I got too many S's there.
He's like
Into a líquido. Líquido. Okay. So, based on what we know, a solution is a liquid dissolved in water and cannot be easily separated. A solute goes into the solvent. Mixtures, two or more materials together. The word dissolve, when a solid disappears into a liquid. How can a mixture be separated? Right underneath this, write me 1 to 2 sentences about what did you learn about a mixture being separated? Go. You're going to answer the focus question right underneath here. 1 to 2 sentences. What did you just learn about can a mixture be separated? Based on what we just went through, can a mixture be separated? If it can, how? Okay? All right, that'll do it for now. What we're going to do after this is go to we're going to go to our mixtures and solutions packet. And I know, right? We're going to, there is a page to fill in that says investigation 1.2 mixtures. And we're going to go through and answer these 4 questions. All right. Thank you for joining us.